In the previous checkpoint, you have learned about the functions of a diode. Now, what happens when you connect wire in an AC circuit? The result is a half-wave rectification of the alternating current. In this circuit, you have an alternating current source, a load, and one diode. Assuming the diode is ideal, current through the external load can only flow in one direction. When we consider the graph of the AC currents, for the first half of the period, the diode is forward biased. Hence, currents flow through the diode and the external load. In the second half of the period, the diode is reverse biased, and hence no or negligible current flows. The first half of the second period is similar to the first half of the first period. Graphically, this is how it looks like. The rectified sinusoidal graphs represent the current through and the potential difference across the load against time. When the currents flow past the forward bias in the diode, the potential difference across the load is retained. In the reverse bias, there's negligible current flow, so there's no potential difference across the load. As seen, although the potential difference in the current across the load is only in one direction, they are both not constant. Let us now look at another example. Instead of a sinusoidal AC, this time we'll look at a sawtooth AC. Based on the graph of current against time, we can tell when there's forward and reverse bias by looking at the sign of the current. Here we assume that the diode has forward bias and the current is in the positive direction. With the diode's half-wave rectification, the current in the reverse bias section simply becomes zero, while those in the forward bias sections remain untouched. Hence, this is the rectified sawtooth AC graph of current against time. In both of these graphs, we see that for the half-wave rectification, only the current from the first half of each period passes through the load, while the other half in the opposite direction is somewhat wasted, and it is not utilized. Is there a way to connect the diodes so we can rectify the full wave instead of only half waves? This will be explored in the next checkpoint.